All right, so I'm going to sit down and do section 2.4 this morning, which is completely different than the first three sections in chapter 2. The first three sections in chapter 2 kind of fit together. They're all geometry sections. This section, there's not really geometry in it. There are some word problems that might have some geometry in it, but for the most part, in this section, we're going to convert from one unit of measurement to another. Like we might change 3 kilometers into miles, or 4 cups into quarts. So we're just going to change from one unit of measurement to another. And in order to do that conversion, you have to have some sort of equivalency. And this sheet that's on the screen right now has most everything that we need for this section to get the problem solved, other than if I wanted to convert from one metric unit to another metric unit, and that's on the next sheet. You don't have to have any of these formulas memorized, any equivalency that's in this section that's given to you. I'll give it to you on the test because I don't have most of these memorized. Well, some of them I do, but most of them I don't. So don't worry about having these memorized. Just need to be able to use them as when they need to be used. So that's one set of equivalencies, and then this is another. This is the metric system, more or less, and it doesn't look so nice in terms of like that meter got split, decameter got split. When I try to blow the font up, it kind of messed up things a little bit, but nevertheless, this is the metric units. So for length are meters, for weight are grams, for volumes are liters. And I'll talk about how to use these charts as we go through the section. I have all the abbreviations just in case you don't know the abbreviations in the metric. So centimeters you probably know, meters you probably know, kilometers you probably know, but you might not know all of these. And again, you don't have to have any of these memorized. You just have to be able to use the information contained in this chart to convert from one unit to another. All right, so first thing we want to do is convert 2,000 centimeters to kilometers, and I told myself I wasn't going to teach moving decimals, but I probably should, because that's within the metric system. If you grew up in a country that used the metric system, you just move decimals. So to convert from 2,000 centimeters to kilometers, I find on my chart centimeters in kilometers. They are 1, 2, 3, 4, 5 steps apart. So to convert from centimeters to kilometers, I'm going to need to move my decimal, and the number of places I'm going to move my decimal is 5 because they're 5 places apart, and I go the opposite direction. So if I'm moving to the right, I move my decimal to the left. So to convert from centimeters to kilometers, I need to move my decimal 5 places to the left. Well, unfortunately, there isn't a decimal written in this number, so I'm going to have to insert it. So there's an implied decimal after the last 0 that's not needed. It's not written generally. And now I'm going to move 5 decimals. So 1, 2, 3, 4, 5. Draw a new decimal in because I need my decimal to go there, and then any place that I've moved my decimal that didn't have a number above it, I have to fill in a 0. So 2,000 centimeters is going to equal 0.02000 kilometers. The 3 zeros after the 2 are certainly not necessary. And so when I wrote an answer to this, I wrote 0.02 kilometers. I won't talk about the way that I did this on the in my write-up because it's way more confusing. If you're converting from one metric unit to another, just grab the chart, count how many spots they are apart on that chart, and do the opposite. So here they're 5 to the right. I had to move my decimal 5 to the left. If I was going from kilometers to meters, the difference between kilometers and meters would be 1, 2, 3 to the left. I'd have to move my decimal 3 to the right. That's the sane way to work within the metric system. Now, converting from liters to cups, which is the next example, that's not within the metric system, so I can't just move decimals. When I'm going between the metric system and the English system, I'm going to have to use unit analysis. So I'm going to have to find on my sheet some relationship between cups and liters, and fortunately there's one that works perfectly. So I find the relationship that mentions the units that I'm changing from. So I'm going to use that 1 cup as 0.024 liters. What I'm going to do now is I'm going to multiply by a fraction. So I'm going to take this 15 liters, and to convert into cups, I'm going to multiply by a fraction. And that fraction in the numerator is going to go the units that you want to end up with. So I will say the final units, or the ending units. And then in the denominator, it's the starting units. So in this problem, I'm starting in liters. I want to end in cups. So I'm going to multiply by a fraction that relates the liters and cups. So 1 cup is 0.024 liters. And in the numerator, I'm going to put the final units, which is cups. And in the denominator, I'm going to put the unit that I started with, which is liters. And now I'm going to do the math. So to do the math, I can cancel out the liters, because this 15 is really considered 15 over 1. So that liter is in the numerator. It will cancel with the liter in the denominator. And now I'm going to multiply what's left. What's left in the numerator is 15 times 1. And then I still have the units cups, and in the denominator my units is gone and I have 0.24 and no units. So now I just need to simplify that, and that's kind of what I have down here. To simplify that, well, I'm just going to go 15 divided by 0.24, because 15 times 1 is 15. So when I turn my calculator on, I'm going to go 15 divided by 0.24, and that gives me 62.5. You can't see that, but if you could see that, it would say 62.5. And I need to attach units to my answer, because that's the whole point. I'm converting from one unit of measurement to another. So my answer to this example, to convert 15 liters to cups, 15 liters is 62.5 cups. So the key to this section, if I'm not converting from one metric unit to another metric unit by moving the decimal, I am going to hopefully find one equivalence that relates the starting unit and the ending student unit. I'm going to multiply by a fraction. In the numerator, it's going to be the units I want to end up with. In the denominator, it's going to be the units that I'm getting rid of. And then I'll just do the math. Sometimes I'll multiply, sometimes I'll have to divide. So next example, I'm supposed to convert between 90 kilograms and ounces. So that's a weight. And the horrible thing about this example is in my weights right here, the only unit I have that has kilograms compares kilograms to pounds. Well, unfortunately, that doesn't get me from kilograms to ounces, but I could get from kilograms to pounds, and then once I get to pounds, I can get from pounds to ounces. Can I? Yeah, because 1 pound is 16 ounces. So this would be a path that I could use in this problem. I could get my 90 kilograms changed into pounds, and then change from pounds to ounces. And usually we do this in one step using 2 fractions. So I'm going to show you how to do it in one step using 2 fractions. So I'm going to start off with my 90 kilograms. I always write what I start with, and then I put a times sign. I need to get rid of the kilograms, and the only relationship I have that has kilograms is this one, so I'm stuck using this one. So I'm going to want to end up with pounds, and I want to get rid of kilograms. Since I want to get rid of kilograms, that's going to go in the denominator, and the other part of the relationship is going to go in the numerator. So I'm going to get 1 pound is 0.45 kilograms. Just doing that would it would change the problem directly into kilograms. In fact, let me just do that. I'll do the problems. No, I won't do that. I'm going to go further. Just doing that would cancel out the kilograms, and that will leave me with pounds. That's not good enough because I want to end up with ounces. So just doing this, my units now are pounds, and I want to change from pounds to ounces. So I'm going to find the unit that relates pounds to ounces. This says 1 pound is 16 ounces. And so I'm going to use that 1 pound is 16 ounces. I put the unit I want to end up with, which was ounces, in the numerator, and the unit that I want to get rid of, which is pounds, in the denominator. So I'm using the second unit, and I'm going to cancel my units again. So this pound and that pound are going to cancel. So the only unit that's left is ounces, and that's good. I started with kilograms. I canceled the kilograms, but I couldn't get ounces. I got pounds. So I canceled the pounds and got into ounces. Now I just need to do the math. And the math is to multiply the 90 times the 1 times the 16. That will all go in a numerator because this 90 is really 90 over 1. So you think of the 90 as being in a numerator. And when you're multiplying fractions, you multiply numerators together, you multiply denominators together. In the numerator of the 16, I have the only units that haven't canceled, which are the ounces. And in the denominator, I have 0.45 times 1. And let me parentheses this up. Maybe it'll make it easier to follow. So I could use times signs, or I could use parentheses. The times signs started to get confusing because my 16 ounces started looking like 160 or 1602. So this is what I need to do on my calculator. And quite honestly, I'm not going to worry about the 1, so I'm going to go 90 times 16 divided by 0.45. And apparently I'm going to get 3,200, but I'll make sure that's correct. So I'll start off, I'll go 90 and then parentheses 16 if I want. I could do a times 16 if I wanted. The 90 could be in a parentheses, but it doesn't have to. And then divided by 0.45, and that gives me 3,200. So the bulk of the mathematics I'm going to rely on my calculator to do. So the answer, 90 kilograms, is 3,200 ounces. So most every problem in this section, at some point we're going to convert from one unit of measurement to another. We're going to just pull off the sheet and try to get our work done. So both 1 and 2, these are the homework problems now, are dealing with metric volume, and it's converting from one metric unit to another metric unit. In this case, I'm going to just move. So for my problem 2, I'll go to my sheet, I'll find milliliters, I'll find liters. I'll count how far is it to get from milliliters to liters. It's 1, 2, 3. I was moving to the right, so I need to move my decimal the opposite direction to the left. So to go from milliliters to liters, I have to move to the right as I'm counting the spaces, which means I go opposite with my decimal. I'm going to move my decimal 3 places to the left. So my 500 milliliters has an implied decimal after the 0, and I need to move it 3 places to the left, which is going to give me 0.500. And for number 2, an answer that's perfectly okay is 0.500. That's probably, and then liters, of course I need units. That's the worst answer, but it's correct. It would be better if you didn't write the 2 zeros after the 5 because they're not necessary. And probably best, usually you don't lead off a number with a decimal, and if there isn't a number to the left of the decimal, you put a 0 in front of it. All of those, if this was a test question, would be correct. Just in case you're not sure on this, we go from 10 meters to centimeters. For you, you're going to use this right here. You're going to start at meters, and you're moving 2 to the left, which means you need to move the decimal 2 to the right. Now, there is no decimal in this problem, so there's an implied. So I'm doing, if you're doing number 1, there's a decimal that's implied after the 10, and this time, because to figure out how many spaces they were apart, I had to move left. I have to move the decimal the opposite way, which is to the right, so I need to move my decimal 1, 2. Decimal's going to be gone, it's going to be here, and anytime I move and there isn't a number that's in the spot that I need, I fill it up with zeros. So the answer to number 1 is going to be 1,000, and then a decimal, and then my unit centimeters. That decimal, because there's nothing after the decimal, isn't necessary. So the best answer to problem 1 would be 1,000 centimeters. Okay, so 3 and 4 will work similarly. I'm converting a number 4 from kiloliters to liters. You're converting from milligrams to grams. So I'm going to do number 4, going from kiloliters to liters. So I find kiloliters, and I count how far to go to liters. I go 1, 2, 3. I had to move 3 to the left, which means I need to move the decimal 3 to the right. I always just do the opposite, so I had to go 3 to the left. To get from kiloliters to liters, I'm going to move the decimal 3 to the right to finish up my answer. So for my 20 kiloliters, there's a decimal that's implied after the 20. I need to move it 3 to the right, so 1, 2, 3 to the right. Decimal becomes there. I fill in zeros, and then I have the decimal that's there. That decimal is not needed. And for number 4, the best answer is 20,000. And then we need the units because I converted to liters. Hopefully you can do something similar for your number 3, going from milligrams to grams. To go from milligrams to grams, you find milligrams, you go over to grams. I had to go 3 to the right, so you need to move the decimal 3 to the left, which means you're going to have to add a 0 into that problem as well. Okay, 5 wants you to go from kiloliters to liters. 6 wants me to go from kilograms to grams. So how do I go from kilograms to grams? I start here at kilograms, and I have to go 1, 2, 3 to the left to get from kilograms to grams, which means I need to move my decimal 3 to the right. So when I'm doing problem 6, I need to move my decimal 3 to the right. So there's an implied decimal after the 8 that's not shown but's assumed. Add my zeros in, and for number 6, the best answer is going to have the number 8,000. Not going to show that decimal after the 0, and then grams. All right, so 2 more here, metric within the metric system, which are the easy problems. I don't need unit analysis. So 8 I'm going to do, going from decimeters to decameters, and going from decimeters to decameters, it's 1, 2 to the right, so I need to move my decimal 2 to the left. So when I'm doing problem 50, I'm going to take my decimal and move it 2 to the left. You're going to move your decimal a bunch of spaces, 1, 2, 3, 4, 5 to the right. So just in case you need to peek at it for the liters. So for yours to go from kiloliters to centiliters, it's 1, 2, 3, 4, 5. I moved left, so I have to move the decimal. You'd have to move the decimal 5 to the right. I moved 2 to the left, so I have to move my decimal. Oops, I moved 2 to the right, so I have to move my decimal 2 to the left. So in number 8, my 50 decimeters, I'm going to move the decimal 1, 2 to the left. And again, I have different levels of answers. An okay answer would say 0.50 decameters. A better answer for number 8 would be 0.5 decameters, and the best answer would be 0.5 decameters. You'd get full credit for any of the 3 answers if this was a test question, but again, if you strive for the best answer, it's just never a bad thing. Alright, so now I'm not within the metric system, so now I'm going to have to find a unit. For mine, I'm changing from feet to centimeters. So hopefully there's a relationship between feet and centimeters, and there is. So for my problem, I'm going to use this relation, that 1 foot is 30 centimeters. And when you're doing, when you're not moving decimals, then the unit that you want to get rid of goes in the denominator. The unit you want to end up with goes in the numerator. For problem 9, you're going to have to use 1 foot is 12 inches. It's on the sheet, but that's one you should probably have memorized. But anyways, for my number 10, I'm starting off with 6 feet. I'm multiplying by a fraction. In the numerator is what I want to end up with. I want to end up with centimeters. And the denominators is what I'm getting rid of. I'm getting rid of feet. And the numbers I'm putting in is 30 centimeters are equal to 1 feet. So now I'm going to cancel the feet. What I have left when I cancel is 6 times 30 centimeters over 1. And the over 1 part I'm not even going to enter. I'm just going to do 6 times 30, which I don't really need my calculator for, but you hate to have mistakes on these videos. I'm sure I've got, enough mistakes by just, trying to do things in my head, or just because I'm stupid sometimes. So might as well not compound the errors. So I'm going to cheat. It's not really cheat, but be lazy. So my answer to this is 180. The over 1 part would be 180 over 1, which is still 180, and the units are centimeters. I think the instructions say to round to 2 decimals if your calculator gives you a decimal answer. So 11 and 12, you need to go from miles to feet, and you're going to use that for number 12. I need to go from yards to meters, and I'm going to use 1 yard as 0.09 meters. Always you start off with the given problem. So I'm starting off with 4 yards. The fraction I'm going to have to multiply by, I want to get rid of yards, so yards going to go in the denominator. I want to end up with meters, so meters is going to go in the numerator. And I have 1 yard is 0.09 meters, so I'm going to go 0.9 meters over 1 yard. My units are going to cancel, and what I have left is 4 times 0.9 meters over 1. When I use my calculator, I don't need the over 1 part, because that's divided by 1, you get yourself back anyway. So I just need to go 4 times 0.9. And then my answer to problem 12, have to have the units in. It's going to be 3.6 and then meters. So if you have if you're taking chemistry, if you have taken chemistry, this is almost a silly section to even do. But if you haven't had chemistry, this could be new. 13, you need to go from liters to cups, and I should show you. There is no. Oh yes, there is. That's what you're going to use to go from liters to cups. I need to go from ounces to cups. Hopefully there's something that goes from ounces to cups. Oh yeah, 1 cup is 8 ounces. So I'm going to use for mine, 1 cup is 8 ounces. For yours, you're going to use 1 cup is 0.024 liters. So for number 14, I start off with 40 ounces. The fraction that I multiply by has to have cups in the numerator because I want to end up in cups. Has to have ounces in the denominator because I want to get rid of ounces. And I'm using 1 cup is 8 ounces. I'm going to cancel out the ounces, and I'm going to be left with 40 times 1 cup over 8 ounces. The ounces are gone, so just over 8. So really I'm just going 40 divided by 8 because I don't need to do the times 1. And when I do 40 divided by 8, I get 5. So my answer for number 14 is going to be 5, and then the units is cups because I canceled out the ounces. Okay, fluid ounces to liters. I made both of these fluid ounces to liters because this is a two-step problem. When I look at ounces, fluid ounces, I see fluid ounces only here, and it's compared, so this should also, well, that's probably fluid ounces as well then, so 1 cup is 8 fluid ounces, but that's, oh well, I didn't, it's okay. Here, I can go from fluid ounces to milliliters, and then I can convert to liters. So on my problem, I'm going to do this in 2 steps. The first step, I'm going to convert from fluid ounces to milliliters, and then from milliliters to liters by moving my decimal. So step 1 for number 16. First, convert to milliliters. And I'm going to start out with my 8 fluid ounces. And I'm going to multiply by a fraction. I want to get rid of the fluid ounces, and I want to end up in milliliters. And the thing that I'm going to use is 30 milliliters is 1 fluid ounce. So I'm going to put a 30 and a 1. And now I'm going to cancel out the fluid ounces. And that's going to leave me 8 times 30 milliliters over 1. And that's 240 milliliters. So far I'm going to have 8 fluid ounces equals 240 milliliters. But I need to convert that to liters. And how do I convert from milliliters to liters? Well, I find milliliters and liters, and I count. To get from milliliters to liters, it's 1, 2, 3 to the right. So I have to move my decimal 3 to the left. So to finish up the conversion, to go from milliliters to liters, I need to move my decimal, because within the metric system, I can move decimals to do the conversion. It's the easy way to do it. I have to move the decimal 3 to the left, because on the chart, to get from milliliters to liters, I had to go 3 to the right, and I just do the opposite. So there's a decimal that's implied there after the 240. And so I'm going to go 1, 2, 3, and then we could have a good, better, best answer. So this would be an okay answer of 0.240 liters. And then there's the better answer of 0.24 liters, and then the best answer of 0.24 liters. So I wouldn't really care, other than it's nice to see the best answer, but it hardly is that big of a deal when I'm grading a test. I don't get that picky. So 15 should work real similarly. Okay, so 17 and 18, we're going from kilograms to ounces, which is weight. And unfortunately, the only relationship with kilograms will take me to pounds. So I'm going to do this with 2 fractions. The first fraction is going to convert from kilograms to pounds, and then the second fraction I'm going to convert from pounds to ounces. So I'm going to do this in 2 steps. So for my fractions are going to be different than yours because you're going backwards from me. So my first fraction is going to get rid of the kilograms and put me into pounds, because that's the relationship I had between kilograms, the metric system, and our English system. And then I'm going to multiply by a fraction to get rid of the pounds, because I'll now be in pounds because the kilograms will be gone. I want to get rid of the pounds and end up in the ounces. So now I just need to fill the numbers in, because those are the units that I need. For your number 17, the first fraction that you're going to have needs to get rid of the ounces, and you're going to use this one, ounces to pounds, and it's going to wind up with the pounds. That will cancel the ounces, and then you want to cancel the pounds So you'd get pounds in the denominator and wind up in kilograms, and you put kilograms in the numerator. So if you insert the numbers and do the math, that's the units that you need. For my problem, the first unit I'm going to use is 1 pound is 0.45 kilograms. So I'm going to go 1 pound is 0.45 kilograms. Kilograms cancel. I wind up with pounds. And then the next unit I'm going to use is 1 pound is 16 ounces. The pounds will cancel. So now what I have left is 6 times 1 times 16 ounces over 0.45 times 1. And when I enter it on my calculator, I'm not going to do the times ones. So I'm going to, or the divide by ones, or anywhere, so I'm not going to enter the ones. So I'm just going to enter 6 times 16 divided by 0.45. And that's going to give me, and it says to round to 2 decimals, so I'm going to write 213.33 ounces. If you wanted to, you can make it into a fraction, but it doesn't ask for that. To make that into a fraction, you'd hit math, enter, and you could say it's 640 over 3 ounces. But because in the beginning of this set of problems it says round to 2 decimals, the answer I really am looking for is this. So this is the, probably just based on the instructions, the best answer for number 18. If you did number 17 and you went and checked your work, the answer I have for number 17 is 11.2 kilograms. So if you got 11.2 kilograms, then you're right. And if you got something different, there's a chance there's a mistake on my key, and then you'd need to, let me know. All right. So you're going from ounces to tons, which is weights, and unfortunately, there isn't a there's a relationship between tons and pounds, but not between tons and ounces. What you're going to have to do is go from ounces to pounds, and then from pounds to tons. So for your problem number 19, you're going to need both of these relationships. You're going to use this one and that one to get you stepped up to your answer. For me, I'm going from yards to kilometers. Well, when I look at my lengths, oh gosh, I have the only length with this is miles to kilometers, so I'm going to have to use this one because it's the only one that has kilometers in it. Ugh. So now I need to get from yards to miles. Well, I can't get from yards to miles, but I can get from yards to feet, and I can get from feet to miles. So I'm going to have to do 3 units. My first unit's going to get me from yards to feet. My second unit's going to get me from feet to miles. My third unit's going to get me from miles to kilometers. So you can have, you can have 10 units in some of these problems. So just me get the units mapped out for problem 20. So there are going to be 3 fractions. And unit-wise, the first fraction, it's going to get from the yards to the feet. So I'm going to get rid of yards, and I'm going to wind up in feet. And that's going to cancel the yards. The second thing I want to get rid of is feet, and I'm going to end up in miles. It's going to cancel the feet, end up in miles, and then I want to get rid of the miles and end up in kilometers, so the miles will cancel, and there's the units I need. So I started with yards, got rid of the yards, got feet, got rid of the feet, got miles, got rid of the miles, got kilometers. Now I just need to put the numbers in. So I know that 3 feet is 1 yard, and 5,280 feet is 1 mile. And lastly, 1.6 kilometers is 1 mile. So I'm not going to put the ones in my work. My math for this is going to be 300 times 3 times 1.6 over 5280. It's kind of pointless to put the ones in there, and my units are kilometers. So I'm going to go 300 times 3 times 1.6 divided by 5280. So 300 times 3 times 1.6 divided by 5280. And my answer is 0.2727 repeating. This problem wants me to round to 2 decimal places, and I'm going to leave the 7 a 7. So for my answer, I'm going to write 0.27 kilometers, or better, 0.27 kilometers. And if you ever give me a fraction answer, I'll never ding you for that. That's always okay too. So if you wrote 3/11 kilometers because you hit math enter, that'd be completely fine. Okay, we're both going from liters to fluid ounces. And to go from liters to fluid ounces, unfortunately, I can go from liters to cups, and this really should say fluid ounces. And then I'm going to go from cups to fluid ounces. So I'm going to do it in 2 steps. The first one I'm going to do is because I start with liters, I'm going to get rid of liters and wind up with cups. And then I'm going to get rid of my cups and wind up with fluid ounces. So, because this here the liters will cancel, there the cups will cancel, and there's my fluid ounces. So the things that I need is 1 cup is 0.24 liters. So 1 cup is 0.24 liters. And then I need 1 cup is 8 fluid ounces. So 1 cup is 8 fluid ounces. Units are all canceled out, so I have 6 times 8 fluid ounces over 0.24. And then this calculator time. So on 6 times 8 divided by 0.24, I get 200 fluid ounces for number 22. Ounces to kilograms. Ours are backwards from each other, but we're going to use the same units just differently. And for the units we're going to use, I can get from kilograms to pounds, and then pounds to ounces. So I'm going to use that one to get from kilograms to pounds, and then that one to get from pounds to ounces. So I'm going to need both of those. And mine's starting out with ounces, so the first thing I'm going to do is get rid of the ounces and wind up with pounds. So I'm going to get rid of the ounces, wind up with pounds. The ounces are going to cancel. Then I'm going to get rid of the pounds and wind up in kilograms. And the kilograms are going to cancel. So my units are all knocked out. I just need the numbers in here. So pounds and ounces, 1 pound is 16 ounces. So 1 pound is 16 ounces. And then kilograms and pounds, 0.45 kilograms is 1 pound. Hopefully you can march through yours okay. For yours, the fractions you're going to need, your first one is going to get rid of the kilograms. And to get rid of the kilograms, you're going to wind up in pounds. So the kilograms will cancel. And then you're going to get rid of the pounds and wind up in ounces. So mathematically for me, I'm going to have to go 220 times 0.45 kilograms over 16. And so it's just 220 times 0.45 divided by 16. And I get 6.1875 kilograms. It says to round to 2 decimals, so I'm going to round that to 9 because the number after the 8 is big enough to cause me to round it up. So my answer for problem 24 is 6.19. I always need units in this section. If you don't put units, you'll definitely lose some points. Tons to ounces for you, which is a 2-stepper, I believe, and kilometers to yards for me. So for tons to ounces, you're looking down here. You can go from tons to pounds and then pounds to ounces. So you're going to use those two. And for me to go from kilometers to yards, I can go from kilometers to miles, miles to feet, and feet to yards. Kind of did this already a little bit differently. So for my 26, I'm going to start with my 2 kilometers, And the only units I have that have kilometers are from kilometers to miles. So I'm going to multiply by the unit that relates kilometers to miles to get rid of the kilometers. Now I want to get rid of the miles, and the only unit that I have that has miles compares miles to feet. So that will allow me to get rid of the miles and end up with feet. And then I can get rid of the feet and end up with the yards. So my units will cancel out perfectly. Kilometers cancel, miles cancel, feet cancel, I'm in yards. And now I put the equivalencies in. The equivalence is 1 mile is 1.6 kilometers. 5,280 feet is 1 mile. And 1 yard is 3 feet. So I have a lot going on here. I have 2 times 5280. And I'm not going to write the 1. I'm going to put the yards in the numerator. And in the denominator, it's 1.6 times 3. To be safe, the denominator probably should go in a parentheses. I'm afraid not to put it. The numerator will never need a parentheses when I break out my calculator. But if there's 2 terms in the denominator that we're multiplying, then when you break out your calculator, you're going to use the divide and you're going to keep the times in the denominator. So that's how I'm going to enter it on my calculator. And so this is going to be 2 times 5280 divided by parentheses 1.6 times 3. That's going to give me 2,200 yards for the answer to number 26. So hopefully these aren't too bad. You know, if you know how to do these already, then this is way too many examples, and I'm almost feeling like it might be way too many examples if you didn't know how to do these, but hopefully these are nice problems. And I still have a few more of these. So quarts to cups, and that's some sort of volume. And do I see quarts anywhere? Well, I see quarts to pints and pints to cups. So that's what I'm going to use. I'm going to go from quarts to pints and then pints to cups. So I'm going to use both of these. And they're nice twos and they're easy ones. So for mine, I'm going to start off with my 8 quarts. Apparently I didn't know how to abbreviate quarts, so I just wrote it. And I'm going to get rid of the quarts and end up in pints. That will make the quarts cancel. And then I'm going to get rid of the pints and end up with cups. That will make the pints cancel. So my units are going to wind up with cups because the quarts and the pints will cancel and the cups will be left. And now 1 pint is 2 cups. 1 pint is 2 cups. And 1 quart is 2 pints. This is a really nice problem because the denominators are just 1. So algebraically, this is just 8 times 2 times 2 cups. I don't need to show the ones. I'm going to get 32 cups for an answer to problem 28. You're going to do something similar, other than these will be flip-flopped somehow, but it should be hopefully understandable. 30, changing from liters to teaspoons. Well, unfortunately, I have teaspoons only to milliliters. So the best I can do is I need to get into milliliters. And it's going to be a 2-step problem. For mine, the first thing I'm going to do is I'm going to go from 2 liters and I'm going to change to milliliters. And I do that with a fraction. I do that by moving a decimal. So I'm going to change to milliliters. To get from liters to milliliters, I find my liters, I find my milliliters. Oh my gosh, it's 1, 2, 3, 4, 5, 6 to the left, which means I need to move the decimal 6 to the right. I got a little crazy. I went from liters. Sorry, supposed to go from liters to milliliters. To go from liters to milliliters, it's 1, 2, 3 to the left, so I need to move my decimal 3 to the right. So I'm going to make my decimal go 3 to the right. So there's a decimal here. I move it 1, 2, 3 to the right. fill in the zeros, and now I'm at 2 liters is 2,000 milliliters. Now I can go to teaspoons. To get from milliliters to teaspoons, I'm going to use that relationship. I'm going to multiply by a fraction. I want to end up with teaspoons. I want to get rid of the milliliters. So I'm going to multiply by a fraction that has milliliters in the denominator, teaspoons in the numerator. And that relationship is 1 teaspoon is 5 milliliters. So my math is just going to be 2,000 over 5. My units are going to be teaspoons. And I believe that's just 400. Just in case you can't do yours, let me do 29. For 29, the first thing I'm going to do is go from teaspoons to milliliters. So I'm going to multiply by 5 milliliters is 1 teaspoon. I'm going to cancel out the teaspoons. You're left with 100 times 5 milliliters. So that would be 500 milliliters. And now I need to change from milliliters to liters. To change from milliliters to liters, I go 1, 2, 3 to the right. So I have to move the decimal 3 to the left, because if I'm moving, I go the opposite way with the decimal. So there's an implied decimal here. I'm going to move it 1, 2, 3 to the left. I'm going to get 0.500 liters. And the best version of that for an answer for problem 29 is 0.05 liters. Since it's an odd problem, I'm checking my answer. So for 29, look at that, 29, I have 1.5 liters. That can't be right. 100 teaspoons. I'm feeling really good that should be 0.5, and for some reason I just didn't write that. I think it should be 0.5. Let me do it again. 100 teaspoons, 500 mil, it should be 0.5. So that I'll change that answer. In a second. All right. Now we're into the word problems. For the most part, the word problems they're just converting, but they just look longer. So this example, 2 cities are 1,000 miles apart. How many kilometers are they apart? This wants me to convert from 1,000 miles to kilometers. So this, as a beginning problem, would have just looked something like this. It would have started off saying 1,000 miles equals something in kilometers. And that's how it would have been written if it wasn't a word problem. So we have to read the words and understand what they're asking me to convert from what I'm starting with and what I want to end up with. Here, I'm starting with 1,000 miles. I want to end up with kilometers. And the unit that we're going to use is 1.6 kilometers is equal to 1 mile. I want to get rid of the miles. I want to end up in kilometers. So I've multiplied by that unit. Cancel my miles. I don't really need a fraction anymore. I just have to multiply the 1,000 times the 1.6. Okay, a 2-part problem. That recalls some geometry. So look at this rectangular prism, and it brought back something from section 9 from 2.3. Find the volume. Well, the volume formula for a rectangular prism is length times width times height, and it doesn't matter what you call the length, the width, and the height. I'm just going to take the 3 lengths and multiply them. So I'm going to multiply the 20 feet, the 5 feet, and the 8 feet, and that will give me the volume in cubic feet. So that's the first part of this example. That's not dimensional analysis. That's just that's just doing a volume formula. Part B says how many gallons of liquid will this hold, and it says 7.48 gallons is 1 cubic feet. And so I probably should have said this volume is 800 cubic feet. And now I'm going to use the unit that 7.48 gallons is 1 cubic feet. And so I'm going to start with 800 cubic feet, which is the volume of that. And I'm going to multiply. I want to end up with gallons, so in the numerator I'm going to put gallons. I want to get rid of cubic feet, so I'm going to put cubic feet in the denominator. I'm going to cancel the cubic feet, put the numbers in. 7.48 gallons is 1 cubic feet, and I just multiply these. And when you multiply those, because it's just a 1 in the denominator, you get the number of gallons, and apparently that comes out to 5984, assuming I did okay with my calculator. Okay, more examples. I'm wearing out on myself, which means you must be wearing out as well. First problem, car has an empty 11-gallon, part A, car has an empty 11-gallon gas tank. Gas is selling for $3 a gallon, which it isn't anymore, but right now it's less than that, but at some point it's going to be way more than that. How much will it cost to fill up the tank? That's not worthy of unit analysis. I'll just take the 11 gallons times $3 a gallon. That's going to cost me $33 to fill it up. Part B is much harder. Assume the gas is selling for $1.50 per liter, which is way more than $3 a gallon. Because how are liters and gallons related? Do I have? Oh yeah. So 1 gallon is 3.8 liters. So it's about 4 liters to a gallon. So 4 liters give you a gallon. Well, 4 liters is $6. So this is about $6 a gallon. So liters are deceptive. It looks cheap, but it's not. So how much is it going to cost to fill up the tank? This is a two-step problem. First, I have to find out how many liters I need. I know how many gallons I need. So first, I need to find out how many liters of gas I need. How do I do that? Well, I just find out the capacity in liters. So I need to convert the 11 gallons gas tank to liters. How do I do that? Well, I use the unit that says 1 gallon equals 3.8 liters. I start with 11 gallons. I want to get rid of the gallons, so I'm going to use this that 1 gallon is 3.8 liters. I'm going to cancel out the gallons. That causes me to multiply. So this 11-gallon gas tank, which cost me $33 to fill up at $3 a gallon, is a 41.8 liter gas tank. And at $1.50 a liter, I take the capacity, 41.8 liters, times the cost per liter, and that's going to give me the total cost to fill it up. So it's twice as much because the gas is way more expensive in some sense. It is way more expensive in every sense, I guess. Yeah, so 6270 is the algebra there. Okay, homework. 31 and 32 basically have the same problem. We have to figure out what we're asked to convert. And in 32, I'm converting the distance from Phoenix to Flagstaff from miles to kilometers. So really, 32 is asking me to convert 140 miles to kilometers, because it tells me the distance in miles, it wants the distance in kilometers. I'm going to use the unit that 1.6 kilometers equals 1 mile, and now I'm going to take the 140 miles that we started with, I'm going to multiply by a fraction. In the denominator, it's the units I want to get rid of, which is miles. In the numerator, the units I want to end up, which is kilometers. The kilometers will cancel. I put my numbers in, and now I just need to multiply the 140 times the 1.6. So I'm getting a little bit lazy because I think hopefully I've done enough of these that you realize that I didn't take the time to write 140 times 1.6 kilometers is what I needed to do here. My answer for number 32, Phoenix and Flagstaff are 224 kilometers apart. I went to NAU between 82 and 86, and back in those days, all these signs that had miles, well, a lot of the signs had both miles and kilometers because they wanted the country to convert to the metric system. It just never happened. So, and a lot of those signs don't exist anymore. Now they just have the miles on them. 33 and 34, same, they're sister or brother problems, and they want me to convert from kilometers to miles. So really, 34 wants me to convert 1,000 kilometers to miles. So I'm starting with kilometers. I want to get rid of the kilometers and end up in miles. And I'm using that same 1 mile as 1.6 kilometers. Kilometers are going to cancel. You're going to have 1,000 over 1.6, and the units now are miles. And I just divide. Somewhere it must have said to round to 2 decimals. I'm going to round. When I go 1,000 divided by 1.6, I'm going to round to 2 decimals. I guess it wasn't necessary. So I'm going to get 625 miles. My stack of papers isn't that thick, but I sense that I still got a good chunk of material to do here. Oh yes. Yeah, so up through 46. Okay. A bathtub holds so much gallons of water, round to 2 decimals. How many cubic feet of water does it hold? Well, we have that lovely relationship that converts gallons to cubic feet, and that's what these two problems want me to do. They want me to convert 50 gallons, in my case, to cubic feet. So I'm giving a starting unit of measurement, 50 gallons, and an ending unit of measurement. And so it's just a longer way to ask the same questions. So I'm going to start with my 50 gallons. And I have a unit that changes cubic feet to gallons. I want to end up with cubic feet. I want to get rid of gallons. So I'm going to put cubic feet in the numerator, gallons in the denominator, and it's 7.48 gallons is 1 cubic feet. So 1 cubic feet is 7.48 gallons. Cancel the gallons. I have 50 and then cubic feet over 7.48. The gallons are gone in the denominator. So I just have to divide. So 50 divided by 7.48, and I get 6.684, and that 4 tells me I don't have to round that 8 up to a 9. If that 4 was a 5, I'd write 6.69, but I'm just going to write 6.68 and then cubic feet. Either the symbol for cubic feet or the words. For me, it's quicker to write the symbol, but you can certainly write the words cubic feet instead of writing a feet with an exponent of 3. 35 should work exactly the same way. So 37 and 38 are like the kind of the example that we did. So part A, it gives me a pool that's a rectangular prism. It's the shape of a rectangular prism. And I'm going to find its volume. So for part A and number 38, the volume of a pool, I'm not going to sketch it because it's going to be embarrassing if I tried that. The volume of a pool that's a rectangular prism is its length, which is 25 feet, times its width, which is 18 feet, times its depth, which is 5 feet, and the units are feet times feet times feet. So I'm going to get the volume is going to be in cubic feet. So 25 times 18 times 5, it gives me the answer to part A. The volume of this pool is 2,250 cubic feet. For part B, I'm supposed to convert this to gallons, and then to convert from gallons, I'm going to take the 2,250 cubic feet, and I'm going to multiply by a unit to get to let me go to gallons. In the numerator, I want to end up with gallons, so I'm going to put gallons in the numerator. And in the denominator, I want to get rid of cubic feet, so I'm going to put cubic feet in the denominator. I'm going to cancel out my cubic feet, and I'm going to use the 7.48 gallons as 1 cubic feet. And now I'm just left with 2,250 times 7.48 gallons. It's going to be a lot of water. And I get 16,830 gallons for 38B. Always important for every problem in this section. In fact, it seems like every problem in this chapter so far need the units, because in the area and volume problems, the units had to be square units and had to have the correct units of measurements. And here too, the units are a big deal. Okay, a little bit trickier because I don't remember the volume formulas off the top of my head and I don't have them with me. So for 39, hopefully you have the volume formulas at your fingertips. I think the volume formula is 4/3 pi r squared h. But before you commit to doing part A of number 39, what is the volume of this, you better find the formula properly, and maybe you can't even read the numbers. So the lengths are 3.2 feet, which is the diameter. You have to divide that by 2 and get 1.6 for the radius, and its height is 1.8 feet. So assuming this is the right formula, you could use those to find the volume, and then we're going to convert from cubic feet to gallons, and it says leave my answers in terms of pi. So when I do 40, I'm going to leave my answers in terms of pi as well. So for 40, again, I think I know the volume formula for a cone. I think the volume formula for a cone is 1/3 pi r squared h. I believe that's right, but I don't 100% know that. And for me, my r is 1 feet. That little mark there means 1 foot. And the height is 2 feet, so my volume is going to be in cubic feet. So my volume is going to be 1/3 times pi times 1 squared times 2 squared. And this is going to be 1/3 times 1 times 4 times pi. So it's really just 1/3 times pi times 4. And I'm going to multiply the 4 and the 1 and get 4/3 pi cubic feet, which would be the volume. Now I'm going to convert that to gallons, and I'm going to leave my answers in terms of pi. So I'm going to start off with 4/3 pi cubic feet, and I'm going to multiply by the unit. In the denominator, I want to get rid of cubic feet. In the numerator, I want to end up in gallons. And it's the same 7.48 gallons as 1 cubic feet. My cubic feet are going to cancel. What I'm going to be left with is 4 pi times 7.48 over 3. And I'm going to enter that without the pi, and I'm going to make it into a fraction. And I guess that's what I want you to do for yours. But why did I? Okay, I'm fine. Thought I made a mistake, but fortunately I didn't. So I'm going to go 4 times 7.48 divided by 3 equals math, enter, enter. So this is 748 pi over 75 gallons. That seems like a stupid answer. Let me look at how I answered number 39. Because it says leave it in terms of pi, which just almost seems silly. I don't know why I decided to do that. So this was 39 I'd be looking at. Your answer to 39. See, on 39, there my answer has a pi, there my answer has a pi, my answer has a pi with a decimal, a pi with a decimal. Seems odd to do that, but let me recalibrate my answers and make them pi's with decimals. So I'm going to go 4 times 3.14 over 3, so I'm using 3.14 for pi, and no, I'm just going to go 4 over 3. This is going to be 1.33 pi feet cubed. And if I do sorry about this inconsistency here. If I do 4 times 7.48 over 3, I get 9.97. So I could have written 9.97 pi gallons. And I have no idea why. because I didn't say give an answer as a fraction, I gave decimal answers. So I would live for part A of number 40 for a fraction or the decimal answer, because it doesn't say to give a fraction answer. And for part B of number 40, I would live with 9.97 gallons or 9.97 pi or 748 over pi. Just because it says leave pi in your answer, I felt leaving my pi in my answer is just good practice, because that's common to leave pi's in answers. So I left it there, and then whether you give me a fraction or a decimal, I guess that's more, and it just seems like if you're giving an answer with pi in it, that you should probably have a fraction, but I didn't. Alright, so hopefully that wasn't completely horrible. Next two problems are the same. This problem right here, 41, you already calculated the volume when you did the homework for section 2.3. So you can go back to your 2.3 notes, grab the volume of that. I'm going to find the volume of my shape. It's a rectangular prism. Volume is length times width times height, and it doesn't matter which I call length, the width, and the height. I just have to multiply the three lengths. So for part A of 42, I get 2 times 3 times 6, which is 36 cubic feet. And then your answer, it tells you to leave, put 3.14 in for pi and round to 2 decimals. Makes much sense. So hopefully you can just snag your answer for part 41A from section 2.3, because we've done this exact problem, and you only have to do part B. For my part B, I'm going to take the 36 cubic feet, multiply it by the gallons I want to end up with, 7.48 gallons as 1 cubic feet. And I just do the math. The gallons, cubic feet cancel. I'm left with 36 times 7.48. And I get 269.28 gallons. If you can't do 41, I just don't feel like doing it on the video right now, you can come visit me or come ask me in class, I'll do it. So 43 and 44 say the speed limit is given in kilometers per hour. What's it in miles per hour? That's the per hour part is consistent, so I just need to change the miles to kilometers for questions 43 and 44. So 44, I need to convert miles per hour into kilometers per hour. Since the only part that's changing is the units, not the hours, or the distances, not the hours. I just need to convert the distances to the right units. So in problem 44, what I need to change is 75 miles to kilometers. So I'm going to start with 75 miles. I'm going to multiply by the fraction. In the numerator, I want to end up with kilometers. In the denominator, I want to get rid of miles. And that unit is 1.6 kilometers is 1 mile. The miles are going to cancel, and I just multiply the 75 by the 1.6. And I get it's pretty impressive, 120 kilometers per hour. It would be kmph, maybe kmph, kilometers per hour. I imagine that's the correct symbol, but I don't know. But it seems like a good abbreviation for now, rather than writing kilometers per hour. So I changed to kilometers, and then it's a speed limit, so I put per hour in. I think last problem. Yes. 1 gram is the same as 5 carats. David's new ring contains 1/8 of a carat. Find its weight in grams. So the beginning thing tells me 1 gram, the first sentence, equals 5 carats. That's the unit that I need for this problem. This was a unit that wasn't in the units on the sheets that I gave up front. Now I want to convert his stone, which is 1/8 carat, to grams. So I know that his stone is 1/8 of a carat, and I want to convert that to grams. And to convert 1/8 a carat to grams, I'm going to start with the 1/8 carat. I'm going to put the carat in the numerator, it's a nicer place for it. I'm going to multiply by a fraction. I want to end up with grams, and I want to get rid of carats. So I have 1 gram is 5 carats. The carats will cancel. I can't write a fraction without a numerator. In the numerator I have 1 times 1, which is 1. The units are grams. And in the denominator I have an 8 times 5. So for an answer, I'm going to write 1/40th of a gram. You could make that into a decimal if you want. 1 divided by 40 is 0.25. You could write 0.25 grams or 0.3 grams. That would be an equivalently correct answer. But a fraction answer is never a bad answer, and if it doesn't say anything about rounding, but I'd live with a 2 decimal rounded answer as well. All right, so that should get us through the section. Hopefully, when I got to the word problems, I wasn't so tired that the lecture really started not being good. Let me know, because if I ever do a lecture and you just find it really just awful, I am more than happy to redo the lecture. All I can do, it just takes an hour and a half of my time, and it's not too much to ask if something just isn't really good enough. So hopefully you have all the odd problems done, and then we have 2 more sections to do. They're completely different. 2.5 is different than anything in the first 4 sections, and 2.6 is different from anything